In this video, we're going to use basic identities to solve our equations. Now, how do you know which tool to use? Basically, you have to, take a look at the equation and see what needs to be adjusted and how. Like, for example, this equation reads sine squared theta equals to cosine theta plus 2. So one thing that I notice here is that we don't have the same variable. We don't have the same trig function. We have sine squared, we have cosine, and that's the problem. The question now is, can we deal with that problem? Can we somehow address this issue? And the answer is yes, because we know how to express sine squared in terms of cosine, right? We know that sine squared is 1 minus cosine squared. So we could do that. We could substitute, and we get 1 minus cosine squared theta equals 2 cosine theta plus 2. So now we have our regular quadratic equation. So what I'm going to do, I'm going to move everything over to one side, probably to the right side, make this side equals 0. So plus cosine squared theta to have cosine squared negative, but it's not imperative. You can do it either way you like. So on this side, we have 0. And on this side, we have cosine squared theta plus 2 cosine theta plus 2, right? So in other words, if we do a u substitution, we're going to have u squared plus 2u plus 2. That's our quadratic equation. And the first intention is to so I'm sorry, this is 1, right? 2 minus 1 is 1. So I have 1 here, 1 here. So if we can avoid using quadratic formula, we would. So what's our actually the go-to method? The first one that we try is to solve by factoring. So, and when you try solving by factoring, you realize that this is a perfect square. This is u plus 1 squared. Okay, so basically u plus 1 squared equals 0. That tells you that u plus 1 equals 0. So now we have u equals negative 1. Now we're gonna actually recall that u was a cosine. So it means cosine theta equals negative 1. And that gives us the answer. It happens only once on the interval from 0 to 2 pi is when theta equals pi. So, and that's it. That's going to be our answer for number 12.